Section 5.8 is simplifying radicals. Our goal is to interpret parts of an expression. On page 344, we have in the solvent, the maximum height of the mirror is a radical expression. A radical expression such as 2 radical 3 or the square root of x plus 3 is an expression that contains a radical. A radical expression is simplified if the following statements are true. First, the radicand has no perfect square factors other than 1. Next, the radicand contains no fractions, and finally, no radicals appear in the denominator of a fraction. So here are some examples of a simplified radical expression. 3 square root of 5, 9 square root of x, square root of 2 over 4, and here are some things that are not simplified. 3 times the radical 12. 12 has a perfect square of 4 because 12 is 4 times 3, so this is not simplified. Square root of x over 2, you can't have a fraction under the radical. And 5 over the radical 7. You cannot have the radical on the denominator. You can simplify radical expressions using multiplication and division properties of square roots. So the first property we have is multiplication property of square roots. For a greater than or equal to 0 and b greater than or equal to 0, the square root of a times b is equal to the square root of a times the square root of b. For example, if you have the square root of 48, you can rewrite that as the square root of 16 times the square root of 3, or 4 radical 3. You can use the multiplication property of square roots to simplify radicals by removing perfect square factors from the radicand. Example 1 says, what is the simplified form of the square root of 160? There is more than one way to do this problem, so I'm going to show you the most basic way and then the way that the previous slide recommends. So first we want to factor 160, so you might recognize this as a factor tree. You think of something that goes into 160, well, since it's even, we know that 2 goes into 160. And 2 times 80 gives us 160. Now, 2 is a prime factor, so we're done with 2, but 80 can be factored. 80 is also even, so we can divide by 2, and that gives us 40. We can keep this pattern going. 40 divided by 2 gives us 20, 20 divided by 2 gives us 10, 10 divided by 2 gives us 5. Now, 5 is also prime, so there's nothing else we can break it apart as other than 1 and 5, and if it's only 1 in that number, we can stop right there because it's prime. So now we have 2 times 2 times 2 times 2 times 2 times 5 will give us 160. The parts that I highlighted in green are what I call the leaves of the tree. These are the pieces that we're going to keep. We don't care about the pieces that have what I call branches coming out of them because it's already taken care of by the pieces below. So the 2 times 5 gives us the 10, so we don't need the 10 anymore. 5 times 2 times 2 gives us 20, so we don't need the 20 anymore, and so on. So we can rewrite the square root of 160 as the square root of 2 times 2 times 2 times 2 times 2 times 5. Now, the way I like to look at these problems is square root means we're looking for pairs of 2. So you want to find however many 2 of a kind you can under the radical once you have found the prime factorization of the original number. Notice we have a pair of 2's followed by another pair of 2's, and then we have a 2 and a 5. The 2 and the 5 don't have a pair, so we don't highlight them. Now, every time you highlight something, that means it's a perfect square. So we have a 2 squared and a 2 squared. Whatever you have that's being squared, you're going to take 1 out of the radical. So the way the square root works, if I have 2 times 2, I can take 1 2 out from that 2 times 2. I have 2 times 2 again, so I can take 1 2 out. So notice I only took 1 purple 2 and 1 blue 2. Then whatever didn't have a pair gets stuck inside. So 2 and 5 is still inside the radical. Now we can simplify. 2 times 2 gives us 4, and 2 times 5 gives us 10. So the final answer would be 4 radical 10. Here is a much faster way to do this problem. If you know right away that 160 is the same as 16 times 10, you can separate radical 16 times 10 as radical 16 times radical 10, and radical 16 is just 4 because 16 is a perfect square of 4. So the square root just looks for what number is being squared under the radical, which is a 4, and then 10 is not a perfect square, and we can't take any perfect squares out, so 4 radical 10. This way is perfectly fine if you see it right away. However, oftentimes you're not going to know which perfect squares are hiding inside the original number. So the factor tree will always work. This only works if you catch the perfect squares on your own. However, the book, of course, does it the quick way. So they just say 160 is 16 times 10, break it apart. Square root of 16 is 4, leave the square root of 10. Now I would like you to try number 1 on page 345, simplify the radical expression square root of 225. I recommend doing a factor tree. Now this one's not even, but it does end in a 5, which should give you a hint as to what you can divide by.